You can check in depth how values are going to be changed inside the loops.
Assalamu alaikum, welcome to day 1 of learning DSA. Today we are going to solve our first logical problem, which is how to find prime numbers in a list. Logic building is not basically a rocket science. This is just ability of your thinking. How you think to solve a problem is called logic building.
I'm not going to set up ID here. I'm using IntelliJ IDEA. You can use any ID which you love and where you feel more comfortable. So here we will just focusing on implementing the right logic and solving our problem. So let's move on to our problem. Find prime numbers in the list. So here we have a list of some numbers from where we will find the prime numbers. So before that, we have to know what are prime numbers. So basically, prime numbers are the numbers who are just divisible with one and itself. Okay, we understand the problem. Now our thinking process, our process of building logic is start. Where we will not directly write code, we will just think how we can verify a number is prime or not. Obviously, we will start dividing number from 2, and if the number is properly divisible from any other number, then it is not a prime number, and if not, then it is a prime number. So how we can write this same logic in the code? First, we will write a logic to check a single digit is prime or not. So for that, I will write a static function is prime number. Okay. Now we will write our logic inside this function. First of all, we will handle a special case. If the number is 0 or 1, then we don't have to check. For that, we will write a number is less than is equal to 1, then return false. Okay, so this is our first case. If the incoming number is 0 or 1, then we just have return false. Okay, this is actual time to write a logic which will check a number is prime or not. So for that, I will write a for loop I into number minus 1. So this is basically arranged in the Kotlin. The loop checks all numbers from 2 up to number minus 1. If the number is divisible by any of these, our function will immediately return false. That means the number is not a prime number, and if it's finished the loops without finding any divided, so this that means our number is prime. So this is our actual magic line which will check our number is prime or not. So let me complete it. If number modulus I is equal to 0, then we just have to return it false. So I add debugger on this loop, and now you will see how loop works and how values are changed inside the loop. A lot of people is confused how what is the value of I in the fifth iteration, what is the value of I in the seventh iteration, how I can check. So all of your these kind of questions will be solved when I will run this program. So let's see for the one more thing I can think this 57 number is too much big. So let me add a number like 13. So okay, first of all we know 13 is a prime number. So let's check it with our logic. Let me run the debugger. Okay, our debugger is successfully came to our this line. Now this will move inside the function. Okay, so it checks, it returns us false because 13 is not less than or equal to 1. So now this is our magic time. See, now currently we have the value of I 2. Number value is 13. So number modulus 2. 13 modulus 2 is equal to 0. Our condition is false because it is not is equal to 0. And now I will update the iteration. You can see number in our number there is 13. 13 modulus I means 3. 13 modulus 3 is equal to 0. The condition is still false, and it will check the same for all the iterations. So you can check at which moment what is the value of I, what is the value of number, and what are the result of the conditions. So this was the thing I want to tell you, the power of debugger. So this is the power of debugger. You can check in depth how values are going to be changed in the inside the loops. Okay, we have successfully write a logic to check a single number is prime or not. Now we will just use this function to check. prime numbers from a list. So for that, I will make a list. Well, prime list is equal to new list of, and that should be 8. Okay. So why I make this prime list? Because we will add our prime numbers to this list and we will print it in the last. Now we have to write our final logic to find prime numbers from these numbers. So for that, let's comment out 8, and here I will write a for loop again. I in numbers. So here I will check for this each number is prime or not. For that I already create a variable, so I will just use it. So I will create a variable where is prime, and I will pass the value of I here. So basically I'm going to just pass the value of our the value from our list in the first iteration, that will be 5. I will pass this 5 to this number and it will check if the number is prime, it will return true, and if it's not prime, it will return false. And on the behalf of this prime number is prime variable, I will add it in the prime list. So for that, if is prime, so I will just add prime list dot add this number to the prime list. So in the last one, we will also print ln and prime list. Okay. So now one more thing you will see here. Now our flow is properly completed. So I'm going to add debugger now to properly track the flow. So let me move the extra spaces to clean this. So let's run debugger. As you can see, our debugger came in the for loop, and it is telling us in the numbers we have these numbers, and I will just shift it to the next line, and here it will check uh, for the first value of iteration, the number we will pass the number of I draw this function, and it will return us true or false on the behalf of the number. So we pass 5 to this is prime number, and it will check 5 is prime number or not. So it will came inside this function, expect it, and let me remove this some debugger. So it will check, okay. In the I you can see we have two. 5 modulus 2 is equal to 0 false, 5 modulus 3 false, 5 modulus 4 false, and okay. So it returns us true. You can see this is actually thing I like about debugger. At the runtime, it is giving me all the values. I don't have to uh, nervous what is the value of y, is this number was prime or not, what is the value of iterations, and as you can see, everything is properly mentioned here. And now the actual magic is, you can see in this prime numbers list it is telling the size 1 because we already checked 5 and 5 was a prime number and it is successfully added to this prime list. Okay, so now the second number came in the list from the list. So basically now it will check for the 6. So 6 you can see properly. 6 modulus 2 is equal to 0. Yes, this is, so condition is true. It will return as false. And now, okay, we just missed one thing because we already checked the condition before we did not break our log. So for that, this is iterating it for the last. Now it will just check one by one for each number, is this prime or not, and add it in the list. So quickly let me check it for all the numbers. Finally, our results are successfully printed. As you can see, if I run the program again, you can see we get the prime numbers are separated from these numbers in this. And congratulations, you solved your first logical problem. And I know there are a lot of other and better approaches to find the prime numbers from the list, but I just cover it in a very basic method. So I hope you like the video. Please share it with your friends and please subscribe my channel. I will see you next time.